Welcome to this tutorial of electrostatics. This is the first session under this topic, and we are going to be dealing with different concepts under it. Now, electrostatics. What is electrostatics? The meaning is coined from the word actually. So we have electron and statics. So, and when we are going to define that, we just say electrostatics is the electric charges at rest. So from here, you can point in two words: electron and statics. So we all know statics as something to be at rest. So I'll just say electrostatics is the electric charges at rest. So that's the simple definition for that. So now, talking about the electric charge, it's always denoted by Q. And what's electric charge? Electric charge is simply defined as the amount of electricity. So that is the simplest definition for that. Amount of electricity. So yes, in our electrolysis, you can remember that Q is equals to IT. So that's when you have current and time. So but here we have a constant for electric charge, which is Q is equals to 1.6 times 10 to the power minus 19 coulombs. So charge is measured in coulombs, and when we are dealing with coulombs, we are going to be making use of this charge. So now, going to Coulomb's law, what does Coulomb's law state? It states that the force of attraction or repulsion is defined as the product of those two charges and inversely proportional to the square of the charges. So of the square of the distance, rather. So the Coulomb's law states that the force of attraction is directly proportional to the product of two charges divided by the distance, the square of the distance. So when it is directly proportional to the product of the two charges, it's going to be inversely proportional to the square of the distance. So that's what Coulomb's law is all about. Now let's look into this question. It says calculate the electrostatic force between two electrons separated by distance of 10 raised to the power minus 10 meter between two charges. Now we already know charges as what 1.6 times 10 raised to the power minus 19. So we have to look for the force. Then you've been given a distance. You have a distance of 10 raised to the power minus 10 meter. Then two charges. I will just repeat these charges since we are not given any specific charges, but we know the constant to be this. I will repeat that charges twice according to the formula. So you'll be having F is equals to KQ1 over Q2 R squared. Now what is K? K is the gravitational constant, and it is 10 raised to the power 9 centimeter square per coulomb square. So that is constant, the gravitational constant. We are going to be using it here. So now your F now will be 9 times 10 raised to the power 9. Then you know that the charge is going to be twice, so I will just square it by 2. So we have 1.6 times 10 raised to the power minus 19 square over, I use the square of the distance, which is 10 raised to the power minus 10 and raised to the power 2. Now when we calculate that on our calculator, we will be having 2.3 times 10 raised to the power minus 8. So 2.3 times 10 raised to the power minus 8 Newton. Remember, it's force we are looking for. Now you can bring this, you can turn it to nano Newton, because if you bring this point here, if you count that number of zeros to the back, it will be minus 9. So I will have 23 times 10 raised to the power minus 9 Newton, which is also known as 23 nano Newton. So that's all for that on this place. We move here. Before we continue, define the type of two charges that we have. We can have positive charges and we can have negative charges. Now what happens to positive charges? We are dealing with positive charges. Charges flow out. So charges flow out. And when we are dealing with negative charges, charges flows in. Charges flows in. So when you are having two charges in equation and they are opposite, it means that they will attract, because when this one is flowing out, it will enter the negative. So but if you are having two same charges, two of them is going to what? they are going to be repulsive. They are going to be repulsive. It's going to lead to repulsive force because when this one is releasing, another one is releasing. You see that they are both doing the same thing, so there will be repulsive force there. But when they are unlike charges, they are going to attract. So in short, let's just say unlike charges attract and like charges they repel. So now you're having two like charges here and you have to find for the force. You have 2 microcoulomb and 5 microcoulomb and you're also given the distance. Now let's look for the force. We are still using coulombs though, and that's kq1 q2 over r squared. Now we insert the k. Remember our k is 9 times 10 raised to power minus 9. So you have 9 times 10, 9 times 10 raised to power 9 rather. And multiply by this 2 are in microcoulomb. You have to change them to coulomb before you can continue. So what is coulomb? That's 2 times 10 raised to power minus 6. So 2 times 10 raised to power minus 6. So that's going to be 2 times 10 raised to power minus 6. Then multiplied by 5 times 10 is to the power minus 6, then all over the square of the distance, which is 0.3 is to the power 2. So when we calculate that on our calculator, our force is going to be 1.0 Newton. That's going to be our force. So that's for that. Now, when the distance is half, you can have maybe an objective question on this. They can ask you when the distance is half, they can ask you when the distance is twice, what happens to the force? So now, when the distance is half, you know the formula to be kq1 q2 over r squared. Now, notice that r is the distance, and when it is half, let's see what happens. Now, when r is what? R over 2. Remember they said half. So when r is 1 over 2, you now insert it here in the formula. You have kq1 q2 over r over 2 then square. So from here you have f is equals to kq1 q2 over r goes this way, 2 also goes this way, so it will be r square over 4. So r square over 4. So now we can bring this outside and we have f is equals to kq1 q2 over 1, then this can come here. If this come here and becomes a multiplication, this 4 will be up. We have r square here. This 4 will be up and the r square will be at the denominator. So we have 4 over r square. So and from here we can bring 4 outside to bracket the rest of it. So we are bringing the constant out. So we are having 4 is equals to 4 into brackets kq1 q2 over r squared. So and we know that kq1 q2 over r squared is also known as f. Is at the initial stage we said f is equals to kq1 over r squared. So that means that our f will be what? 4f. That means when the distance is half, our force will be what? Will be 4 times. The force will be 4 times. So I'm just going to give a quick table. You can prove it also in the comment section. So this is the quick reference. When the distance is over 2, the force becomes 4f. Then when the distance is over 3, the force becomes 9f. So you can always check this for reference when you are studying. So thank you very much. Do well to like, share, subscribe and comment.